NEC 517 addresses the specific electrical requirements for healthcare facilities, with a significant focus on patient safety through equipotential grounding. These requirements are primarily applicable to new patient care areas within healthcare facilities. The core of the system involves creating a robust grounding infrastructure. This includes the installation of a grounding grid or a plate electrode. The code mandates a minimum of 4 grounding electrodes, each spaced at least 6 feet apart, to ensure effective grounding. An equipotential grounding plane must be established around the patient care area. The specification in the question states this area to be within 100 feet of the perimeter. This plane aims to minimize voltage differences in the patient environment. To achieve this equipotential state, several elements must be connected to the grounding plane. Firstly, all conductive walls, floors, and ceilings within the designated area should be connected. Secondly, all exposed metal surfaces of electrical equipment must be integrated into the grounding plane. Thirdly, metal framing and support should also be bonded to the grounding system. The grounding conductors themselves are subject to specific requirements. Solid copper conductors are required, and their size must adhere to the specifications outlined in NEC tables 250.122 and 250.102. These tables provide guidance on conductor sizing based on the overcurrent protection device in the circuit. It is critical that these grounding conductors are run independently of the power and lighting circuits to avoid introducing noise or interference into the grounding system. These grounding conductors must be securely connected to the grounding grid or grounding bar, ensuring a continuous and low impedance path to ground. The grounding resistance of the entire system must be verified to be less than 5 ohms. This low resistance is essential for the effective dissipation of fault current and the minimization of voltage potential differences. In addition to these technical requirements, coordination with the building owner or architect is necessary to ensure that the grounding system is compatible with the overall building structure. Thorough testing of the grounding system is mandatory to confirm continuity and proper resistance levels. All aspects of the grounding system installation, as well as the results of testing, must be meticulously documented for future reference. The electrical contractor bears significant responsibilities in ensuring compliance with NEC 517. These responsibilities begin with the design and installation of the grounding grid, equipotential grounding plane, and the associated grounding conductors. The contractor must also carefully select and install appropriate grounding electrodes to achieve the required grounding performance. Rigorous testing of the grounding system is required to verify compliance with all applicable NEC 517 requirements. The contractor is responsible for documenting every aspect of the grounding system installation and testing procedures. Comprehensive documentation must be provided to the building owner for future reference, maintenance, and any necessary modifications. In summary, the electrical contractor's role in a hospital project requiring equipotential grounding around a 100-foot perimeter of the patient, as per NEC 517, involves several critical steps. Firstly, design and install a grounding grid with at least 4 grounding electrodes spaced no less than 6 feet apart. Secondly, create an equipotential grounding plane within 100 feet of the patient area's perimeter. Thirdly, connect conductive walls, floors, ceilings, exposed metal surfaces of electrical equipment, and metal framing to the grounding plane. Fourthly, use solid copper grounding conductors sized per NEC tables 250.122 and 250.102, running them independently of power circuits. Fifthly, ensure the grounding system's resistance is less than 5 ohms. Sixthly, coordinate with the building owner to ensure system compatibility. Seventhly, test the grounding system for continuity and resistance. Eighthly, document all installation and testing results. These steps are crucial to meet NEC 517 requirements, ensuring a safe electrical environment for patients and staff in healthcare facilities.